and 4.4. I would skip over this one because we did a lot of adding yesterday. However, we need to look at the factoring here. Okay? Because I can guarantee the factoring is not obvious to some of you at first. Once you see it, I think you'll get it. But we need to be able to factor. Okay? Remember, first step, we need to work to get that common denominator. So factor what you have. How does x squared minus y squared factor? Because it does. Do you guys see it? Difference of squares. It's no different than, for instance, when we did x squared minus 4. It was x plus 2, x minus 2. Exact same thing. It's just with two variables. So x squared minus y squared factors into x plus y, x minus y. And unless I took it out, there's one like that in the homework. Okay, and it could have ended up coming out when I was rearranging homeworks. But what about x plus y? That denominator is good to go. Okay, and kind of a hint when it already matches one of the other pieces, right? So what are we going to do for our least common denominator? What matches? We have an x plus y in common. What do we have in the way of leftovers? An x minus y. So my GCF is going to be that, not GCF, whoops, least common denominator. It's going to be x plus y and x minus y. Okay, if you recall what I was doing yesterday, I like to write out two fractions. If you want to jump and go straight to one fraction, that's fine. So my common denominator, I'm going to write out for both of them. It's x plus y, x minus y. Okay. First fraction. What's missing from my common denominator? What's missing from my denominator? X plus y, x minus y? Nothing's missing, right? If my denominator is already there, then my numerator just carries down. Second fraction. What's missing from that denominator? Yeah, it was x plus y. We also needed to have an x minus y. If we multiply the bottom by x minus y, multiply the top by x minus y. So this numerator is going to be 8 times x minus y. You want to go ahead and distribute that there, by all means. Okay. Do the steps as you see fit. My next step, what I've been doing is I've been taking my two fractions, putting them together as one fraction, right? We don't want to cancel anything. Okay, we want to keep that common denominator. So I'm going to pull my two fractions together with common denominator, x plus y, x minus y. And then I can put my numerator pieces together. We know we have x plus 3y. Note, this is a plus sign. Always pay attention. And what do you know about 8 times x minus y? Yeah, distribute, and it is plus 8x minus 8y. Okay. And clean up that numerator if you didn't already. What kind of like terms do we see? X plus 8x is 9x. 3y minus 8y is minus 5y over x plus y times x minus y. And anything I can do to that numerator? 9x minus 5y, there'd have to be a numerical GCF, and there's not, so we're going to stop there. Okay. So that refresh your brain of what we did yesterday. Okay. Now, what are we going to do on the back side? We just spent a bunch of time adding. Now we're going to spend a little bit of time subtracting. And in homework, they will very possibly maybe mix together. On a test, they'd be mixed together. So just be aware here. Other than the fact that we have to subtract, is there any real difference? No. We still need a common denominator, so that process still has to happen. Okay. I'm probably only going to do 2 of these, just time-wise. We got to get to the scary looking part at the bottom, right? Okay, so I don't know if you guys have looked at the bottom, but I can guarantee it's scary looking, right? Doesn't mean it is scary. It just looks scary. Okay, but let's subtract. What about denominators? What about 3y plus 15? Yeah, 3y and 15 both divide by 3. So if I factor out 3, I now have y plus 5. 5y plus 25 also has a GCF. This time both can divide by 5. So if I factor out a 5, I'm left with y plus 5. Probably not a surprise at this point, right? You're realizing there's usually something in common somewhere. I'm not saying there has to be, but usually. Okay. Now, what about this least common denominator? In common is a y plus 5, yes? What are my leftovers? 3 and 5. So with that in mind, there's a leftover 3, a leftover 5, and the y plus 5 that's in common. When I think in terms of my common denominator there, I usually put the 3 and 5 together. Kind of like, what do we have, a 2 and an x, or something and an x yesterday that we put together. Same idea. So 3 times 5 is 15. So I personally think of it, my common denominator is 15 times y plus 5. If nothing ends up canceling, that's what Thomas would want to see. However, if you'd rather leave it as 3 times 5 for the moment, you could. Okay. Note, you need to make sure you write a subtraction sign this time. I'm going to write in my common denominator. Thank you. Okay. 15 and y plus 5. What's that first fraction missing? We had y plus 5, y plus 5. We had 3. This is a 15. What do I need to do to get to that 15? We're going to have to multiply by 5, right? So officially, when you look back over here, we're missing the 5. If we multiply by 5 on top or on bottom, we'll multiply on top. So that's going to be 5 times y minus 1. If you went ahead and distributed that, that's great. Second fraction, what are we missing? Got the y plus 5, got a 5. It needs to become a 15, so how do we get there? Multiply by 3. What we do on bottom, we do on top. So this is going to be 3 times y plus 3. If you want to go ahead and distribute before you put them together, you can. I'm going to go ahead and put them together as one fraction, I think. Denominator of 15 times y plus 5. First fraction. 5 times y minus 1 becomes 5y minus, did you say 1 or 5? Okay. I heard it right, and then as I started second guessing myself, I'm like, I'm not sure if she said that right or not. Okay, now, what's happening on this second fraction? We're distributing the 3, yes? What kind of 3 should I think of that as? I would think of it, and there's different ways we can do this, but because this is a minus, I would think of that as a negative 3. Does that make sense when I distribute it? Okay, so negative 3 times y is going to be minus 3y. Usually we get that one. This is the one we forget. Think of it as a minus 3 times 3, or negative 3 times 3, which is a minus 9. Does that work? Okay, somehow or another, don't forget that subtraction sign. Okay, and it's no different than what we've been doing. Clean up. 5y minus 3y is 2y. Minus 5 minus 9, whoops, too far, is going to be minus 14 over 15 times y plus 5. What do you think? Is there anything else we can factor or simplify? Yeah, we can at least do a GCF on top. Even if nothing cancels, I recommend you're in that habit. So the top has GCF of 2. You factor out 2, you have y minus 7. Still over 15 times y plus 5. Obviously, y minus 7 and y plus 5 don't cancel. What about 2 and 15? Do they have anything in common? Not this time, right? However, that's a key place you could see something in common. If 2 and 15 basically reduce, make sure you reduce them. So in this case, this is another where either or are going to work. Always at least double check that factoring. I feel like I'm going to play eeny, meeny, miny, mo here. Do I want to do A, or do I want to do B, or do I want to do C? I think we're going to do B. Because I did one, yeah, C on the front side kind of reminds me of this C. So I've done a big one like that. That's why I wanted to double check. So, okay, let's go ahead and do B just for one more subtraction practice, and then we'll worry about the complex fractions. Okay? So, maybe I don't even need to do B at this point. I don't know. What are we thinking in those denominators? X squared minus 1. 2 parentheses, right? Difference of squares again. X squared is x and x. The square root of 1 is 1. So it's plus and minus 1. What about my denominator of x minus 1? Nothing to do with it, right? So, do I even need to ask? Do you know what your least common denominator is? X minus 1's in common. And leftover, we have an x plus 1, yes? Okay. Are you guys at the point you can stay ahead of me? Common denominator, x plus 1, x minus 1. X plus 1, x minus 1. I'm putting it in both fractions. What about my first fraction? What's my common denominator missing? Or what's my denominator missing? Nothing? X plus 1 is there. X minus 1 is there. So, all that needs to happen is the 4x needs to come down. Second fraction, what's missing? X minus 1 is there, so we're missing x plus 1. What we do on bottom, we do on top. So this is going to be 4 times x plus 1. Okay. Put it together. X plus 1 times x minus 1. First fraction is 4x. Second fraction. Okay. We need to distribute the 4, and what do we need to remember? It's a minus, right? So I would think of this as a minus 4. So if I do minus 4 times x, this is the easy one to get, minus 4x. What's the catch? Minus 4 times 1 is going to be minus 4. That's the sign you're going to forget if you're going to forget one. The goal is just don't forget one. Okay, what cleans up? 4x minus 4x is gone. Leave me with negative 4 over x plus 1 times x minus 1. Anything cancel, factor? No. Okay. As I said, we're going to skip working out C. However, if you are so motivated and you tried it and you want to see if you got it right, or you want to try it, I will tell you what the answer is. It's 12 times x plus 1, or 12x plus 12, over x minus 8 times x plus 4 times x plus 2. So, if you get motivated, you want to try that. There's the answer. It's not different than anything else we've been doing. Okay? The process is the same. It reminds me of C from the front side, where we had to have 3 factors in the denominator. Okay? Now, the bottom part. Okay? We call these complex fractions. They're complex fractions because, not because they're scary looking, but because they're fractions within fractions. Okay? When we start seeing fractions within fractions, that's complex fractions. Now, our goal is to get them in a more workable form. And there's really 2 different ways, 2 or 3, really 3 different ways I could come up with, depending on the situation. I'm going to teach what I think is easiest. Someone else says, no, that's not how you do it. I do it this way. I'm not going to say there's not other ways to do these. Okay? But here's the deal on A. We have fractions within fractions. Do we want fractions within fractions? No. So your job is to get rid of the denominators that are within the denominators. Which means I need to get rid of what? What are my denominators I need to get rid of? An x and an x. Now, just like what we were doing, we're going to think least common denominator. But our least common denominator is of the denominators that are within the fractions. Okay? So my least common denominator, we have x here, we have x here, so what's my least common denominator? X. It's already there, yes? But I ask about it because that's what we're going to use to multiply. So our job then is going to be to multiply the numerator by x and multiply the denominator by x. Okay? And we can do this because multiplying by x over x is just 1. If you multiply something by 1, the value of it doesn't change. So that's why you can multiply something by 1,000,000 over 1,000,000. And it doesn't change the value because you're just multiplying by 1. Now, with this in mind, when we multiply that numerator by x, what are we going to have to do? That x is going to have to distribute. It's going to multiply by both terms. What are we going to have to do in the denominator? That x is going to have to distribute. It's going to have to multiply by the x and the 2 over x. Okay? Now, for teaching purposes, for hitting everybody at all levels, I'm going to kind of write this out in an extended way. You may not need this once you see it, but I'm going to write out my original problem, which is the 2 minus the 1 over x. And I'm going to write next to it, what are we doing next to each piece? We're multiplying the 2 by x, and we're multiplying the 1 over x by x. I'm going to do the same thing in the denominator. I'm going to write out the x plus 2 over x. What are we doing to both pieces? We're multiplying them by x. Okay? And again, I think it's going to help some of you see it. Now, it's all about cleanup. Okay, so on top, 2 times x is 2x. Easy enough. Minus, what is 1 over x times x? No. So what is my red x here? What is x as a fraction? To make anything a fraction, you put it over 1, yes? The math teacher in me says, what can I do with those x's that are on the diagonal? I personally like to cancel, and then we're just multiplying 1 times 1 over 1 times 1, which is a whole bunch of 1s. So this just becomes minus 1. Now, otherwise you could have said it becomes x over x, but what's x over x? It's also 1. So one way or another, are you okay with that? Okay, same thing on the denominator. We're distributing that x. X times x is x squared plus 2 over x times x. Well, what do we think of this x as? X over 1. You can say 2x over x if you want, but that's not how I like to do it. What am I going to say? My x's cancel. What remains? 2. It's 2 times 1 over 1 times 1, if you will. 2 times 1 over 1 times 1. But that's just 2 over 1, which is 2. Okay? So a bunch of excessive 1s, but that's 2. Okay. Well, first of all, does that look a lot neater? Okay. Your first and main goal is to get this so we no longer have fractions within fractions. And no longer have fractions within fractions. Your next goal is what we've been doing last lesson, this lesson. Is there any factoring and reducing we can do? Okay. Is there any factoring? Huh? Not exactly. It's not x squared minus a number, so it's not going to factor. 2x minus 1, we can only talk GCF. Guess what? You're done. Okay? And I know some of you want to think already. Doesn't seem like we should be done already, but we are. Okay? The big challenge, yes, there will sometimes be more simplifying to do, but really the big challenge is how do I get rid of the denominators within denominators? And I'm going to suggest we find the least common denominator of those denominators and multiply by it. Okay, questions on that one? Not until we see the next one. Okay, let's look at B. I got fractions added and subtracted within fractions and fractions within fractions. Okay, I got to get rid of those denominators. Okay, what do you see in your denominators? There's x, there's y. So what's my least common denominator going to be? X times y. Okay, just take every factor that's in your denominator and multiply them together to get your common denominator. Okay, so look for things in common. There's an x in common, there's a y in common. There's no leftovers past that. So what are we going to do? We're going to multiply the numerator by xy, and we're going to multiply the denominator by xy. Now, what's that mean I'm going to have to do again? You're distributing again. Every time when there's multiple terms, you're distributing. Okay? So, now, again, not saying this is a required step. Some of you start multiplying, you're going to have your answer, you're good to go. But if there's the slightest bit of confusion, write it out. I'm going to take 3 over y plus 7 over x. And what am I doing to both of those? Both of those are getting multiplied by xy. Same thing in the denominator. I'm going to take 1 over y minus 2 over x, and both of those are getting multiplied by xy. Now, because we're multiplying xy by a fraction, how do we make xy a fraction? Xy over 1, yes? So all of these can just be thought of as xy over 1. Okay. Well, let's see what happens here. One fraction at a time. 3 over y times xy over 1. What can cross cancel? A y can cancel with a y. We can do that because it's x times y. You can cancel a factor. What remains? 3 times x, which is 3x. Plus 7 over x times xy over 1. What can I cancel? X and x cancel, leaving me with what? 7y. Repeat in the denominator. 1 over y times xy over 1. What cancels? A y cancels, leaving me with 1 times x, or in other words, x. Minus, I just copied my minus sign down, 2 over x times xy over 1. X's cancel, leaving me with 2y. Looks a lot better, doesn't it? I no longer have fractions within fractions, which is my main goal. Is there any factoring I can do? No, it'd have to be GCFs. There's no GCFs. So you're good there. Are we catching on a little bit? Okay, let's go look at C when you're ready. Start thinking. What kind of common denominator do you want to multiply by? What are you guys thinking? AB? Okay, and here's the deal. On top, we have an A. We have a B. Okay? Down here, we have an AB. Well, what do you get when you take A and B and multiply them together? AB. Okay? So my common denominator I'm going to multiply everything by is AB. So we'll multiply the numerator by AB and denominator by AB. Now, there's a slight difference on this setup, isn't there? Okay? On top, what are we still going to have to do? There's 2 fractions, so that AB is going to have to distribute. On bottom, how many fractions are there on bottom? There's just one big fraction here. So it's not going to be a distribute. It's just multiplying AB by that one fraction. Okay? So let me write this out. We're going to have 1 over A plus 1 over B. And those are both going to multiply by AB. Shall I go ahead and ask, how do we make AB a fraction? Put it over 1, yes? Second one, or denominator, we have one fraction here. I can't split this fraction up. It's A squared minus B squared over AB. So that one fraction is getting multiplied by AB, which is AB over 1. Okay. On top, 1 over A times AB over 1. What cancels? What remains? Okay. Plus 1 over B times AB over 1. What cancels? B cancels, leave me with A. Denominator. A squared minus B squared over AB times AB over 1. What cancels? A and B cancel, yes? So AB cancels with AB. What remains? A squared minus B squared. Okay, again, it looks 100% better. We no longer have fractions within fractions. Same question I always wrap up with. Is there factoring I can do? And there is factoring this time. Do we see it? I know some of you do. We started off the day factoring x squared minus y squared. Okay, that was D on the front side, yes? This is the same thing as factoring that x squared minus y squared. Now, B plus A, just B plus A on top. A squared minus B squared. It's variables, but it's the difference of squares. Got to start recognizing that. A squared breaks into A times A. B squared then is going to break into B times B. If it multiplies to be a minus B, plus and minus. Anything cancel? Okay. Our question, does A plus B and B plus A cancel? Is 1 plus 2 the same thing as 2 plus 1? Yeah, it's 3 either way, right? So, yeah, they can cancel. Now, what remains as my final answer? What's on bottom? A minus B, that's the easy part. What's on top? When everything cancels, what remains? 1. Yep. Okay. Now, does that 1 have to be there? Absolutely. This is not the same as saying A minus B is my answer. It's 1 over A minus B. Okay? So yes, we finally got to one where canceling matters. Okay. I don't know if D looks more scary or less scary than what we've been doing. In my brain, it's just different. And I hate to single one out and teach a different approach, but I'm going to. Okay? The difference between this one and the other ones, besides the fact it just looks different. My other ones had fraction plus fraction or fraction minus fraction within fractions, right? What do I have here? I have, in my brain, one big fraction on top divided by one big fraction on bottom. Does that make, do you see that difference compared to the other three we've just done? With that in mind, here's what I like to think. I like to break this out. I can do this because it's one fraction divided by one fraction. And I like to think of this as x squared minus x minus 12 over x squared minus 2x minus 15 divided by, what are we divided by? X squared plus 8x plus 12 over x squared minus 5x minus 14. I'm not going to say there's not other ways to do this, but this is the way I like to think of it. Now, 2-3 days ago, I taught how to do this. This is lesson 4.3. How do we do fraction divided by fraction? What's our magic phrase? Keep, change, flip. Multiply by the reciprocal. Can we use that approach? Yes, this is no different than a problem you would have seen back in 4.3. It's just they stacked it vertically instead of writing it out horizontally. So I would now then say, okay, let's keep. So I'm going to keep x squared minus x minus 12 over x squared minus 2x minus 15 I'm going to change. Division changes to multiplication. And I'm going to flip. So now this fraction becomes x squared minus 5x minus 14 over x squared plus 8x plus 12. And what are you going to have to do? Factor, 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 factor? I said x, we're going to factor 4 times.
Will you please have Brooklyn Shear, Sierra Cowan, and Serenity Legan to the high school office, please? Thank you.
Okay. I'm going to go quick here because I'm running out of time. X squared is x and x. Multiplying to be negative 12, adding to be negative 1.
Today during homeroom, we will have
4 and 3.
in Chippy's room for middle school, and we will have a art club meeting in Mr. Huntley's room.
Okay. Are you guys okay with negative 4 times positive 3 on that top one? Denominator, multiplying to be negative 15, adding to be negative 2. Negative 5, positive 3. Second fraction. X squared is x and x. Multiplying to be negative 14, adding to be negative 5. 7 and 2. Negative 7 plus 2 would give me the negative 5. And x squared is x and x. Multiplying to be 12, adding to be 8. 6 and 2, 2 and 6, however you want to look at it. And in everything we do, after we factor, we cancel. What cancels? X plus 3 on bottom cancels with x plus 3 on top. X plus 2's cancel. Anybody else? So let's make it one big fraction. On top, x minus 4 times x minus 7. On bottom, x minus 5 times x plus 6. Okay. I'm not going to argue that there's not other ways to do that problem. Okay. To each their own. If you're shown something else and you really like it, go for it. If you come up with something else, go for it. Okay? Folks, you've got lesson 4.4 to get done. Okay? What? Oh my gosh, I did it again. What is up with this? Okay. You do have lesson 4.4 to get done. And now it says lesson 4.4. Okay. Not sure why I keep doing that. Okay, guys, make sure you get that done. We've got lesson 4.5 next week to finish up the chapter.